Hello and welcome to another video from Double Rail. Today we've got another 15 minutes modeling, and it is Monday, December 2nd, 2019. So here I have Walter K Whigham, and it's a old Hornby A4. Now Hornby have actually come out with this locomotive again in a newer model, but mine's still works perfectly fine. Well, it did until a few minutes ago, but basically it's 60028 in British Railways experimental blue livery. And I'm gonna, if you listen real carefully, I'll show you exactly what the problem is. So when I apply power, you can hear the motor spinning, but it's not moving. Do the other way. It's spinning and not moving. Now, this particular locomotive is tender driven, and so the problem is in the tender. And as I was moving it down the track with my hand, this particular cog fell out. Now this is the cog from the center of a ringfield motor, and what's happened is over time this thing expands and moves around, and then eventually just pops off. And so sometimes you can get it back on, other times it's just shot and you need to get a replacement. Now what I'm going to do today is I'm going to replace this and hopefully get this loco working again. Okay, so first of all we need to create a new tool to be able to open the tender. Usually I use a credit card, but today I'm going to use Blender to create a new tool. So the first thing I'm going to do is open up our template file. Now I'm thinking I might make this template file available to people to download, so we'll try to make that available. But once it's loaded up, what I'm going to do is add a mesh. So you click on add mesh and cube, and this creates a giant 2-meter cube. So what I'm going to do next is up in the upper right hand corner, I'm going to change the location settings and just zero them all out. This puts it in the center of the basically the plane. With them all zeroed out, I'm going to go and then adjust the settings to the size of the object I want. So I'm going to set the X, Y, and Z values, and lo and behold, I now have a basis for my tool. And this is going to be like a little credit card type tool. So what I'm going to do now is just export it as an STL so I can load it into the 3D printing software. However, I want to show you a quick trick as well. You can use the edit mode and then hit, which is tab, and then select the corner, and let's change the one axis of the corner. So it's about a millimeter back, and now it's kind of slanted that. And you do that on the opposite side as well, and then all of a sudden you've got a new tool. So with that done, I'm going to import it into Cura, which is a slicer, and then I'm going to tell it to slice the file. And then I'm just going to go and check in the preview just to make sure that it is correct. So this is how it's going to 3D print. So we're going to go send it over to the 3D printer and see how it works out. Okay, so we've got our tool that we've put together, and it's printed, so I'm going to use this tool here. Basically remove it from the printer, and it comes off very easily like that. Then we're going to strip the this is the brim, so it's gone, and we're left with the final product. You can see there it's beveled on one side like it was in the design. One thing that you will notice is that it's not as big as it looked in Blender. And that's just the side effect of the software. It just kind of magnifies things. But this has turned out pretty well. It's flexible, kind of like a credit card, but it's also thinner, so hopefully it'll work pretty well. So I'm going to run a sandpaper block over this just to smooth it out a little bit and take some of the sharpness off the edges, and then we'll go test it out on the tender. Okay, so we're back here at the workbench. I've run the tool over some sandpaper real fast just to smooth it out on the outside edges. Now this is the tender. It's firmly in there, and so what we're going to do is, you'll notice there's a little lip here and a gap there. I'm going to go take the one edge that we raised, and we're going to put it through there like so, and I'm going to run it down here, and voila, it's popped right off, and we can get access to the tender. It's real easy. So if you like this tool, I'll go stick it up on Tracksite 3D this week. Might make it available for free. It was pretty simple, so maybe we'll make it one of the freebies. We'll see. So you can see here what the problem is. Our cog is missing. So what I'm going to do next is figure out exactly why the cog is missing. There's not really any play in it, so I'm guessing the cog just expanded and popped off, and that just happens. Sometimes it gets lubricated, sometimes metal breaks down, sometimes it's just fatigue in the metal for the cog. So we have a couple of options, and one of them is to maybe use the 3D printed cogs, because I've already 3D printed cogs for ringfield motors, and they work pretty well. So I might try that. Since we already 3D printed the one tool, why not 3D print the missing part as well. Alright, so this is the original cog. You can see that it goes in there okay. The problem is it comes right back out way too easily, right? So it's going to go around a few times and it's going to pop out. There may have been some kind of washer or something holding this on, or else it really did expand or wear out over the years. So I have two options. I have one, I can 3D print this cog and see how that works, and I could also 3D print something that's going to keep this cog in, like some kind of washer or something. And now I previously designed a cog and a washer for this purpose, but you can see this is just, the hole is too small. So the last ringfield motor that I used, the spindle here, must have been smaller. So I'm going to go get the digital caliper and measure the size of the spindle here, and then we'll go and redesign the Blender file and 3D print a replacement part for this. Alright, so this is a set of digital calipers. So we're just going to go and turn it on, and you can see there it'll give us a reading, and I'm going to go put it around the spindle, and it's telling me it's 2.4, 2.41, and so I'm going to go turn this off, and we're going to go use that measurement to put a new hole through the original 3D printed design here, and we'll see if that gives us the part that we need. Alright, so to create the new part, we need 2 cylinders. The cylinder you see selected here is a 2.65 diameter cylinder, and it's going to be our cutting cylinder. And so we've selected now the actual part cylinder, and I've just set that to a certain size. We're going to use the Boolean modifier to cut the one cylinder from the other. So we use Boolean difference, select carve, and then select the cutting cylinder. And then once that's selected and applied, we basically go through and delete the cutting cylinder, and you'll be left with the final part. So what we're going to do next is export this as an STL and then take it into Cura, send it to the 3D printer, and then we'll test it out on the layout. Okay, so we're back over here on the layout. Ultimately, what I decided to do was to 3D print this kind of washer clip that goes over the end. So I put the original gear back in because there really wasn't anything wrong with it other than the fact that it slid back and forth. And so what I've done is I've put this little plastic piece in. It's pretty tight, it's snug, goes over the edge, and I've been running it now all afternoon and it hasn't given any problems whatsoever. So I'll give you a quick demonstration so you can see it working. But basically you can see there it holds the cog on there and is hasn't fallen off yet. So I'm gonna go give this a few more tests, but it's looking like a pretty good solution. And then what we'll do is maybe in tomorrow's video you guys can check out how it's been performing after it's been running for a while. Alright, so that's it for today's video. Hope you guys enjoyed it, and until next time.